Cool. So I'll just start by thanking Kevin and Leah and the organizers because it's been an awesome event. So thanks, guys. Thanks also to the sponsors who, without their assistance, we couldn't have had the event. I'd also like to make a couple of plugs before we start the conversation. One, I run the London Bitcoin Developers Group. So if you're ever in London or you're interested in speaking, please look up London Bitcoin Devs on Twitter or Meetup. There's a bunch of really good meetups, Bitcoin technical meetups, either being set up. There's one in Boston. There's a bunch all around the world being set up. So check those out. And also, if you're interested in setting a meetup, please contact me and I'd be happy to help. I'd also like to do a quick plug to John Newbury, who's doing some amazing work in terms of encouraging people to contribute to Bitcoin Core. So if you're interested, if you haven't previously contributed to Bitcoin Core and you're interested, there's an IRC group every Wednesday where John will answer your questions and help onboard you to start making your first contributions to Bitcoin Core. So that's a really awesome initiative. Okay, so let's start. We'll do introductions. Introduce yourself and the Lightning project that you're working on.
Cool. My name is Olaoluwa, or Olaoluwa, people call me Roast Beef. I'm co-founder and CTO of Lightning Labs, and I work on L&D, working on Lightning stuff for maybe about 3 or so years on design, protocol stuff, implementation, other high-level stuff too.
My name is Justin. I'm a software engineer at Berryfill. We were the first one to offer Lightning in a merchant commerce when it launched.
My name is Matt Corallo. Have been doing Bitcoin protocol design work since 2012-ish. I also have a Lightning library, so it's designed to fill the niche of existing wallets who want to integrate Lightning in an easy way. Existing Bitcoin wallets that have all of the on-chain state handling and all of that stuff already implemented and don't want to duplicate it. They can just kind of take this and it does most of the Lightning specific work for them. But they still get to use all of the stuff they already have and don't have to download the chain twice or anything like that.
Cool. So as we start the discussion, it's worth considering that we're still very early in terms of Lightning development. So it's a bit harsh to judge Lightning by the same yardsticks as we would Bitcoin. Lightning's what, 3-4 years now? 3-4 years old?
Yeah, it's 1 year on mainnet or so.
Yeah, so it's very much still training wheel stage, but we will explore the security of the Lightning Network as a whole and the individual implementations. So firstly, Lalu, what's your view of the security of LND as a Lightning implementation in its current state today?
Yeah, I'd say it's pretty good, getting better every day. So I think it's definitely getting better every day because we have a lot of users actually giving us feedback in terms of maybe they realize certain accounting holes. And I think every now and then we also discover things even on the protocol level as far as maybe different ways of probing or maybe other ways, holes that we didn't know before. And one thing we've really been focusing on in the past year or so is a lot of safety measures in L&D. For example, we have the seed backup. We have this thing called SCB, static channel backups. We have watchtowers now. Definitely really focus on making sure that things are secure and actually robust, such that people maybe exchanges and whoever else on feel more confident in the software they can use it in the future for their needs. So it's definitely getting a lot better.
Cool. Did you get that, Brian? It's a miracle how he does it. Okay, cool. So Justin, you've been building on top of L&D. What's been your experience of building on top of L&D? We'll try and focus on the challenges. Obviously L&D offers so much out the gate, but let's try and focus on some of the challenges of building on top of L&D.
Well, I've been testing out L&D since before I was hired at Berryfill, so I've had experience working with it. I would say we're aware of the risks of using it, so I would say one of the challenges was keeping all of our money in hot wallets online. Basically, users pay us and we have a channel balance that we cannot get rid of or close. I mean, we can close the channels, which we've done, but it's sort of been a growing hot wallet due to the amount of users, in my opinion. API-wise, I would say it's been getting better and better. A lot of things that we've didn't know would be a problem, we've seen as a problem testing it out the software on mainnet with real users. So yeah.
Cool.
What problems?
Well, originally we liked Lightning because we wanted to get away from all of the on-chain problems. So as an example, as a merchant, if you have incoming payments often from users around the world, you have many of them send partial payments, many of them overpay, many of them send you half a Bitcoin in accident, which sounds really scary. With Lightning, we hoped that it would sort of make this experience better. So incoming payments wouldn't be underpaid. I think overpayment is a feature, but it doesn't really happen often except with C-Lightning. So that's one reason.
Cool. And so, Matt, you've taken a very different approach with Rust Lightning. Like, it's not trying to do the exact same thing that L&D is doing, and like early on, you've been trying to work out like what niche you can operate in. So, like when you observe L&D with like being a prolific Bitcoin core contributor, like what are your thoughts on how it's evolved? Would you have done things differently, and any lessons in terms of building Rust Lightning?
Well, I mean, there's kind of, I guess there's two parts of that question. The first just being, obviously, I think they've been doing great work. C-Lightning's done great work. Async, Eclair have done great work, among others. And so there's not really any help in me trying to compete with that. There's just redundant effort. It's just a waste of everyone's time. And so, as you mentioned, trying to find kind of a niche that's useful for people who want to, for example, run their entire Lightning wallet on a machine that's only connected to the world over a serial cable, right? So no internet access required. You can build something reasonably. I mean, obviously you have to have kind of pseudo-internet access. You have to be able to pass messages to your peers, but it doesn't have to be over an IP stack. You don't have to expose a full IP TCP implementation over your critical machine that is holding all your private keys, right? And you can do more flexible things around the ways you do watchtowers, right? So that machine, you might send kind of encoded watchtower blobs to multiple watchtowers and get those watchtowers to agree that they have seen this update before you move on. So you can really kind of distribute your security model a little bit there, but that's obviously a lot more work on the user's end. That's not, let's say, development user, not a average user. And so it's a completely different niche, right? Like L&D is not targeting a hardcore developer who wants to integrate it into their app and do a bunch of work themselves and like very micromanage exactly how data is stored and all those things. And does great in its niche, and then it's a rather separate niche to try to say, okay, you want to micromanage exactly how this works. You want to have some higher security arguments about what's going on, et cetera. The other angle that Rust Lightning has taken is because of that library, we've been able to do really cool work with automated fuzzing and trying to analyze the state machines in automated kind of fuzzy fuzz testing style ways. So just throw garbage at the state machine, see if it is able to maintain state with a peer, do all kinds of weird things, reorder messages in ways that's much harder to test for other implementations. But so that's been fun and interesting, but Lightning's still really early. I'm sure everything else will get there eventually. And at the same time, I don't have to worry about users, so I don't have support tickets, don't have a lot of people using it yet. Gives me free time to work on other things.
So one of the use cases Matt is looking at is like existing Bitcoin wallets integrating Lightning into their existing wallets. Like, is that a possibility with L&D? Do you think Rust Lightning is better placed for existing Bitcoin wallets, or like yeah?
That's a good question. Yeah, I mean, so definitely with Rust Lightning, it's definitely designed from the ground up for that purpose. Like it's possible with L&D as well, but like with L&D, you'd probably have to so there's kind of like a few fundamental abstractions to L&D, kind of like signing, getting blocks, notification for confirmation, things like that. You can kind of abstract those things out, but maybe it would require you to have them be different processes, perhaps, right? So maybe the signer calls actually another process that's it's not within the L&D process itself, but it's still pretty modular. But it's not designed really to be integrated to other wallets. You kind of like have L&D as the full stack wallet itself. So it does a number of things. Additionally, like you can get like keys from it. There's arbitrary signing. It's kind of like meant to be more barriers included, for example. And even with that, we see many people actually build wallets on top of L&D. There's there's probably like maybe more mobile wallets most of L&D now, or with other wallets than before, because it kind of like gives you like an easy jump start, for example. But if you did have a very specific use case, like maybe for Rust Lightning, you could kind of like more carefully architect what you're doing with your wallet. While with L&D, you kind of like inherit many of our design decisions. While if you had a more kind of like library format, you'd be able to really do things specifically to your exact use case. It's kind of like two things. One, like completely barriers included, that you accept it. Here's the RPC. Here's everything that we have. The other one, you can kind of like really just have the particular pieces. Maybe if we implement some parts yourself, and kind of like mix and match to kind of like maybe like choose your own Lightning node type of thing. Where you have like all these pieces that you plug in together. So different approaches, which I think are both valid, and it's cool that we're exploring with them at the same time.
Cool. I feel as if I should always give Brian at least 3 seconds. Good. So Justin, so building on top of a Lightning implementation, you said something about C Lightning earlier. So are you monitoring the other implementations, or are you focused on providing services on just top of one?
So initially, when I started implementing it for Berryfill, it was before it went on mainnet, any of the implementations. So the one that was ahead at the time was LND, so I went with this first. I didn't bother looking at the other implementations. So I took some looks, but the APIs weren't far enough, and they weren't ready for mainnet. So initially, we went with LND. What I learned from running LND after a few months, or maybe even years at this point, was all the bugs that needed to be changed on the API level. And basically, it was really useful to have the LND team on Slack, where I can just message them and say, hey, this is an issue, I can file it, and they would fix it. That's generally been the style how I've been working with LND. Yeah.
So Matt, obviously Lightning is a layer 2 system rather than a layer 1. That means that there can be a faster pace of development, even though you don't necessarily want to go completely crazy and not have sufficient review and make sure users aren't losing their funds. What insights do you have from a Bitcoin Core perspective? Do you think Lightning is going too fast? Do you think there should be more review? Do you think an implementation like LND is sufficiently stable?
I guess I don't have as much experience running LND as Justin does to answer the maybe specific stability question, but obviously, all of the layer 2 systems that we have today and all of the kind of proposals for reasonably sane layer 2 systems have this property that they've taken the kind of censorship resistance assumption that we have in standard Bitcoin land that's kind of a weak assumption about usability, right? So if you lose censorship resistance temporarily or you lose censorship resistance period, this is a usability issue, but you don't necessarily lose funds, and all of a sudden this has been hoisted to a kind of fundamental security assumption where if you can't get a transaction onto the chain quickly enough, you lose money, right? That's fundamentally the security model of Lightning, and really all other layer 2 systems that have been proposed that are at least not super centralized, right? So that's kind of a different world and is still something that is, I think, kind of the biggest question about Lightning security is more kind of in that domain of just, Bitcoin's still an experiment. We don't know how decentralization is going to work out. We don't know how censorship resistance is going to work out in the long run. And so, while it is important for scalability that we look at these things and try to utilize them into building these second layer systems, we don't have any really better ideas. It's still kind of a big open question in the long run. That said, in terms of kind of the pace of Lightning development, I think the protocol is actually moving not that quickly. It's moving obviously much quicker than you see Bitcoin consensus rules moving, but it's still moving at a reasonable pace when you compare it to kind of other more flexible protocols, other protocols that have lots of users, but also can be changed freely because you have upgradability on a per connection basis, on a per peer basis. And so Lightning, I would say, is moving at a reasonable pace in that kind of context. It's maybe a comparable pace to the peer-to-peer logic in Bitcoin Core, right, where new protocol messages, new optimizations are added. It's a similar pace there as you see in Lightning, just as you would expect, because they have similar constraints, right? You just have to negotiate certain, whatever the options are with your peer, and then you use that with that peer, but it doesn't have to be the same with all your peers. So I would say it's kind of similar. Obviously, you see fast-paced development just in the clients themselves, just because they're new, and users flooding in, high pace of adoption. So you see a lot of bug fixes, a lot of tweaks, a lot of fast development, but that's also to be expected for relatively new software projects.
Yeah, definitely. And I feel like, Lightning has the possibility to kind of like be a little more nimble in Bitcoin development because like, there's probably maybe like 3 or 4 classes of different updates. For example, like there's something called kind of like the end-to-end principle in like network technologies where you can kind of like, add new features at the endpoint and not really modify the actual core of the network itself. For example, like, there are people who talk about these features, allow you to kind of like send a payment to another node without an invoice. I call it like key send now. For example, that can be updated, that can be run on Lightning today without updating any of the other intermediate nodes, right? So only if the sender and receiver actually have this new thing, they can do that. So I think it's pretty cool because it allows for a lot more flexibility from the developer side of things. Main developers are very excited about that because all of a sudden now they can kind of like have an idea and just like implement it, as long as they know the client and the receiver actually have this new feature. So I think that like, the ability to do a little more agile there is pretty exciting because we can think of new ideas and like incorporate them pretty quickly other than kind of like, more fundamental things in the network. For example, like an example of kind of like a more fundamental upgrade in the network is maybe moving to maybe D-log-based, HTLCs versus the hash-based one. The current hash-based one has an issue in that like, because it has the same identifier in the entire route, I think maybe this pointed out in an earlier talk, then you can actually identify, you can identify the route if you have 2 intermediate nodes, while the D-log one is going to require kind of like more of like a hard fork in the network in a sense, because you would require them to actually have that new upgrade, and maybe that would have, kind of like a period. We have both of them initially in the network, then you switch to one of the other ones. So I think it's pretty cool that we have like a bunch of ways you can upgrade the network in the future. You can do that as kind of like a quicker pace, but as always, because it's decentralized, we can't just like flip a button and upgrade everybody. It's kind of like still like an opt-in thing. So if people don't want an upgrade, they can just sit there and maybe don't want to accept it. But hopefully, they uptake security updates or big improvements in privacy or the scalability of the system itself.
And obviously the flip side to that fast-paced development is that you can really get new features out the door quickly and see what works and what doesn't. So like, obviously we're focusing on security today, but there's obviously that positive flip side to that fast development process. Do we want to discuss Rust versus Go as languages?
We're on stage.
We haven't had too much controversy this weekend.
Ooh,
I feel as if...
I don't know if I'm awake enough for religious
What's
debates. I don't know if I'm awake enough for religious debates right now.
Okay, so I win, Go wins then? Okay, we're cool. All right, let's move on.
You heard it here first. Go is a better language for a Lightning than Rust.
I'll do the previous discussion.
Yep.
So right now, I have taken a look at all the other implementations. Well, not Rust, Lightning, because that's not really a node together right now. But I have for Eclair, for example, I've been testing, experimenting with new features that LND does not support. So it's not to throw away LND, it's more of to try both of them in experiments. So one of the things we did was with turbo channels. So basically, it's a way, in a custodial context, we're able to sell a pre-funded channel to a user, and if their wallet supports it, they're able to use Lightning instantly when the transaction is unconfirmed. This doesn't have to modify the network at all or anything, it's just between me and the other node. Another example would be raising the channel size limit. So what we did is we removed the limit, and any other node that also has these rules where you can fund a bigger channel also can do this with us. So Async did this with us. They opened a 1 Bitcoin channel, and I think a 2 Bitcoin one.
Yeah, and for those who don't know, like the current limit on Lightning today is like 0.16 BTC. It's kind of like a training rule type of thing, but you can just lift it if you want, but it's not really rolled out widely yet.
Yeah.
Cool. So that's like the individual implementations kind of covered. Like let's move on to like cross implementation, and so looking at it from a network level in terms of multiple implementations. I'm aware that Christian Decker has a GitHub repo where he's testing compatibility between implementations. Like, do any of you have views on like the state of the Lightning Network in terms of cross implementations?
Yeah, I mean, so he has those tests. The tests aren't like fully encompassing, but it's kind of like a very basic thing. That was something that we had initially just to ensure that, okay, we can actually send payments over channels with each other. But like, since then we discovered like a number of like little quirks. We work pretty closely with developers of C Lightning and Eclair. They always like, have bug reports between us because maybe many times like we're testing LND to LND and like, okay, everything works, whatever, our job is done. But then maybe there's some like weird thing with Eclair or C Lightning, and that's something that we're definitely doing a lot more work on. And, the cool thing about having that series of tests, there was another new implementation called Ptarmigan. They were kind of like based in Japan, focused on kind of like embedded systems. Like they were able to use those tests to kind of at least have some rough certainty that things were partially compatible. But I think we can definitely be doing a lot more in terms of kind of like fuzz testing, like Matt's saying, like which is pretty good to ensure that your implementation can both do kind of the happy path, but also just won't kind of like crash if it gets some like random data or something like that. But definitely something I would probably start to invest a little bit more in the future on because it's very important that like it's not just kind of like an LND to LND, which is like C Lightning is kind of like a big network where everyone can actually interoperate properly. Because otherwise, then you kind of have these like segments where it's kind of like not really connect to anything else, which we don't really want. So, yeah.
Right, fuzz testing's not just for crashing though, right? Like you
Oh,
can't
yeah,
do,
not just, but
so,
kernels as well.
I mean, Rust Lightning has been doing protocol level fuzz testing, right, where the fuzzer's the input from the fuzzer, you use that as a list of commands to, send payments, connect nodes, disconnect nodes, reorder messages, so, things that you would only see if you have very strange internet behavior where you have multipath, right? This exists, it's not common, but it's also entirely possible. And so do kind of really poke at all of these edge cases so that you can really test the state machines and really test the actual behavior of the nodes and not just, okay, do you read over a buffer when you're deserializing something? Do you overallocate memory? Something simple like that. So I'd really like to integrate other nodes into that, but it's really hard to take freestanding daemons that aren't kind of libraries. So, maybe I'll spend some more time with the Claire trying to do that, but haven't gotten around to it yet.
Yeah, definitely valuable stuff.
In my experience testing out the software, running a node on mainnet and having like hundreds of channels, initially when...
Yeah, like thousands? You were like
no,
over
hundreds,
1K?
hundreds.
Yeah, hundreds.
Not some private channels.
Okay, yeah.
What I've seen is initially when all the implementations launched on mainnet, they were constantly having issues with each other. Like they wouldn't connect, they wouldn't stay connected.
Or channels get
force
force closed.
Yeah, so it's just an endless stream of reporting issues, sharing the bug logs with all of the teams. But I mean, lately, there still have been issues here and there, but it's been getting better. In my experience.
So like, obviously we've had the discussion for years on whether multiple implementations are good on Bitcoin Core. Like on Lightning, it's interesting because there are some parallels, but there are some things that are just completely different. But generally,
In this case, you go to chain and no one loses any money.
Yeah.
And consensus, worst case, you fall out of consensus and everyone loses lots of money.
Yeah, so definitely the risks are like pretty different in terms of like you're saying, like, if things mess up, you can just close the channel versus like, being on some other different chain. So we can kind of like take a little more risk perhaps, knowing that we kind of have the base chain to fall back to, so.
Cool. Okay. So let's move on to like end user security. So I suppose the big two developments for end user security would be watchtowers and static channel backups. Anybody want to talk about the current state and what the ideal future state would be for watchtowers and static channel backups? Whoever wants to take it.
Yeah, so that Lightning walls is a little more difficult than regular walls because you have like additional state. With your regular wall, you basically just have like your seed, and you have your seed, and you can input that and kind of do a rescanning of your UTXOs. While with like Lightning walls, you basically have that particular state of your channel. And the difficulty there is like if your state is out of date, you can potentially have like an accidental breach, which can cause lots of funds. Which is something. So we developed like this kind of thing we call an SCB, static channel backup, such that it's kind of like it's not like a snapshot of every single state, but it's kind of like the initial information necessary to close out a channel in the case something goes wrong, right? So we try to make it kind of like as foolproof as possible. That like what you can try to kind of like have like an up-to-date state and just hope that this is the correct one, but that's kind of like that can be potentially risky if you don't have like a very strong consistent system on the back end. So instead, it's something that allows you kind of like reconstruct the channel and then just go to the other party and then actually close it out. It's kind of like a thing there. So now you have basically your seed in this like special file, and typically the file only gets updated when you open and close your channel. So it can be on your iCloud maybe. Because the other thing is as well, like I've seen that for many users, their channels are pretty stable because they want to keep the channel open for a long time. And closing a channel is like a pretty bad thing to do. Anytime like a user has an issue, like, do I have to close my channels? I'm like, yeah, sorry. Like, oh man, like, I want to keep it open. And then the other thing, of course, is like watchtowers, which were like developed like a bit ago. I remember like Tad had like early versions back in the day, and like Connor and I have been working on this new versions, which will be on LND 0.7. It's kind of like still like an earlier version, but I feel like having that out there is pretty good because it's good from like point of view of incentives. It's kind of like a deterrent of like any type of funny business now, right? It's like there could be a tower out there could be like 5 of them, there could be like you don't really know what's out there, so it really adds an additional level of deterrence. And like we've seen some breaches on chain, maybe due to kind of like accidents or people testing it out, but I haven't really seen like a large scale like targeted breach or something like that yet. But now that they have this kind of like nuclear weapon on, sitting on the back, maybe it'll be less likely to occur in the future.
Also, still relatively small amounts of money in Lightning, right?
Yeah.
It is still at the end of the day much too early to start putting lots and lots of money in it. There's still bugs that people see, nodes that crash, not to mention questions about some of the specs not quite there in terms of like fee estimation, looking to the future, stuff like that. That makes, if someone actually breaches, it can be hard to punish them in the current design. These are all resolvable issues. It's just still early, and so you wouldn't actually expect to see large-scale exploitation because there's just I mean, there's some money in it, but it's not.
It's not too much. Yeah, it's also interesting. It's like, we have like a
Not gonna
lot
walk
of
away with
code.
$1 million.
Yeah, we have like a lot of code that we've like tested and like really, evaluated, and but ideally it never executes. It's basically just there like a deterrent. Like, hey, we have the code, don't do anything funny. So it's kind of like a thing where like there's some asymmetry there as far as like we're pretty good versus kind of like how often it's executed. But it's good to have that code there, and then like I can sleep at night because I know that like we tested it and it works. We've seen it in the wild, so we can catch breaches, people cheating, which is definitely good.
Do you think the talk of increasing those limits on payment channels with Wombology is a little bit premature?
Wombology. Oh, you're saying, do I think it's premature? I mean, so like I'd say like my personal point of view, I feel like maybe like the supply of capital network maybe kind of outstrips the demand of it. So I think we have like a good bit of money based on the current level of traffic on the network. But like I feel like it probably makes sense today for companies that kind of like doing very frequent transactions between each other. And we don't really want to rotate the channels very often. I think the other place where it will make sense in the future is kind of maybe for exchange, but I don't think we're really quite ready yet just there. But like he's saying, people can do it today because there's no global consensus. Like they just open a channel and like, all right, no one can do anything about it. And so yeah.
Yeah, like right now it works. Nodes will route through it. Legacy clients will route through it. They'll pay us just fine.
Yeah.
So it hasn't been an issue. I think in the context of like B2B, it makes sense to like raise the limits. I mean, it makes no practical difference for us. Like Claire has been opening many channels. So instead of having to open like 5 transactions to open a channel with us, they can just open one Bitcoin. There's many nodes on the network that already have 1 Bitcoin worth of channels to us. That's when it could just be one.
And especially when you actually really know your counterparty.
Too.
Yeah,
If they really do something and try to steal a bunch of money, you can sue them. There is a fallback.
Yeah, true. Yeah.
Have you looked at watchtowers at Bitrefill? Any plans to offer a watchtower?
I don't think any of them are production ready, but I think LND has a pull request. I sleep better at night that we have the static channel backups, because previously it was just a reckless running a hot wallet without, if you have any data corruption and I fall back to an old state, I mean, I lose all the money.
Yeah.
At this point, it's probably not something we want to lose.
No, definitely not.
Yeah.
Of course. And Stefan Snigarev talked about hardware wallets on Lightning earlier. It's a difficult problem. But I don't know if you've spent much time looking at how hardware wallets would integrate with LND. Perhaps it's a little early for Rust Lightning. I don't know. Inform me.
Yeah, I mean, so I thought that was a great presentation. I also have like many similar ideas in that frame, and I feel like the main difference between like kind of a hardware wallet in Lightning context versus like a regular hardware wallet is like I feel there's a lot of opportunities to kind of like add more states to the wallet to make it more intelligent. For example, you could do something like the wallet only signs what it knows to be forwards, doesn't sign what it knows to be kind of like outgoing payments. It doesn't maybe doesn't sign duplicate payments. So I think if you can add like a lot more kind of like state into the hardware wallet itself, then you can add a lot more security. For example, like let's say you're an exchange, you can add security to ensure that okay any outgoing payment must be user initiated withdrawal on the exchange, otherwise rejected and stuff like that. I think there are also a number of kind of like interesting things as far as like topology when you're running kind of like your node to kind of like have what we call kind of like a gateway node structure. Where you have like a main node that's actually exiting a public channel from the network. And you have another node that's behind it, which maybe has like more funds that can allow you to kind of like really control what's going on because you can basically like shut off that one channel to ensure it's blocked out from the rest of the thing. But so yeah, I think wallets will definitely hardware wallets definitely interesting. We don't really have plans yet explicitly to build them out, but I think it's very cool research because like once you have that there and you have like towers, you have backups, you also have like hot replication as well. And I think it's a pretty interesting state to be in as far as kind of like the security and safety of the system. So I think it's inevitable, especially when we have like much larger channels than we do right now. Because right now maybe you have like a few $1,000s in a channel, but like eventually it could be millions of dollars, and you definitely want like the key security to be in hardware at that point. And also kind of like segmented from the main daemon.
It is difficult.
I'm sorry. Supporting hardware wallets is an explicit goal of Rust Lightning, but it is a very different model from I think what's currently the like C Lightning. What do they call it? HSMD, and a lot of the existing research. The model is more, it's tricky, right? So there's a lot of issues with just trying to enforce the rules on the hardware wallet end against the Lightning implementation running on the machine, right? Because if, for example, you have 2 different channels that have different dust limits, which is completely acceptable, completely realistic if you have different counterparties who have different fee rate estimates, all of a sudden you might receive payments right at the dust limit and then forward them, and then you can't enforce these rules anymore. And could get your money drained if you disable these rules on the hardware wallet, right? Or you have questions about, well, if you broadcast a transaction because you think something's about to time out, but it's just because you haven't received the latest block, then all of a sudden your hardware wallet, or the machine upstream of your hardware wallet, which was compromised, caused you to lose money. Right, so the Rust Lightning approach is a little different, move all of the complexity onto the hardware wallet, right? So it's not feasible with today's hardware wallets, which run with really absolutely tiny CPUs and 128 kilobytes of memory or something like that. Instead, it says, well, put 5 megabytes of memory in your hardware wallet, run the full Lightning daemon there, and pass the actual messages that you want to send to peers off onto the computer, which then sends them upstream. You do routing and other similar things on the actual computer. Obviously, you don't keep the routing table on the hardware wallet or anything like that. And then for watchtowers, which of course you have to have security, you have the hardware wallet have kind of a list of trusted watchtowers, which are remote third parties, and it sends watchtower updates to them via your potentially compromised machine, but it waits for the watchtower to actually provide a signature saying, yes, I've received your update, before it moves forward with the channel, right? So it's a very different model in the sense that you don't get the benefit that some of the existing designs try to achieve, where they have kind of effectively 2 nodes that have a lot of logic about Lightning, enforcing rules against each other, but you still get the benefit of today's hardware wallets, which is the keys are on a machine that only connects via a hopefully simpler protocol than full TCP/IP stack, doesn't run a web browser, all of the kind of crap that you have today with at least many Bitcoin wallets, right? So it's a little bit different model, but I think there's at least some potential there. Of course, it doesn't work with today's hardware wallets. You'd have to actually upgrade the CPU in them. So
Yeah, and I feel like memory is important too. Like it'll be a lot beefier than like a ledger as we have it today. So
right, it does still, however, make sense in, for example, a server context where you might say, okay, we're going to run a server. We're going to buy a server. We're going to run Lightning node on that, and then we're only going to connect to the outside world via a serial connection, right? So you can have a lot better assurance of everything that can come in and out of the machine than running a full Linux stack that is exposed to any machine that can connect to it on the internet. You can be a lot more careful about that. But
I mean, at a high level, the biggest challenge is that, like, if you're using a hardware wallet on chain, you just have to monitor the chain when you're submitting a transaction.
Yeah, and you also
with Lightning, you have,
okay
if you're a routing node and you've got a hardware wallet, you're having to monitor the chain potentially 24/7, right?
Yeah,
right. Well, not necessarily monitor the chain, but you still have to be online if you want to route, right? Even if you're not monitoring the chain, you still have to be online to route. So it is a very different model.
Yeah, like the big difference also on chains, like in every single transaction you're going to explicitly approve, you're going to click OK. While with Lightning Wallet, it's ideally going to be making automated decisions for you, kind of like we had a similar talk about like automated wallets, and like you have to be very careful about that, because otherwise, if it can just kind of like steal all your money, it's not really doing anything. It's kind of just like a security thing. So it needs to have like verification to ensure that what it's doing is correct, and definitely could be tricky as far as implementation to make sure that's actually secure.
Cool. Any thoughts on hardware wallets?
I mean, I'll use it, but I recommend exchanges to do this at some point. Or maybe in a user context. I mean, you don't have to be online all the time. Your node becomes a watchtower when you unplug your device or something, watching. There's different models.
Cool. So let's talk probably about the most controversial topic, and then we'll open it up to questions if we've got time. On-chain fees.
Yeah.
Right. I've got a question. What exactly? I don't know if he wanted to get credit for the question, but I'll read it as is. As a security guarantee, Lightning Network requires that a channel can be closed on-chain at any time. So in opening a channel for a payment in which the on-chain fee level is significant in relation to the payment, is one not foregoing that guarantee altogether?
Yeah, that comes up a lot. I feel like my response to that's kind of like, that's like a thing for like any output in general. Like you're not going to make an output on chain that's going to be more costly to actually move it yourself. But like I feel like in Lightning, depending on the context, there's different ways you can actually deal with those fees. For example, we're talking about the breach case. Like on the breach case, because you actually you're entitled to all the money of the counterparty that's actually cheating you. You can actually bleed their funds away into the fee for your like just a transaction, right? So as a result, you can kind of do a thing where you say, okay, well, everything he has goes to miners, and I'll be made whole. So there's some things you can do there as far as like being able to get in. But you are right in terms of like fees are definitely very important. Because right now, like the current Lightning protocol has limitation where the fees are basically pre-committed to for every single committed transaction, which means you're locked into that 5 choice you provide or whatever else, right? We're doing something in the future. We're going to do it where you such that you can kind of like actually add minimal fees to the closing transaction, but then later on actually update that fee via kind of a child pays for parent type of thing to ensure that you can get into the chain. Because otherwise, if you're offline for a long time and you have like a very low fee rate, you may have difficulty getting in because you can't actually update the fee on the committed transaction as is right now. But that's something that we're definitely looking to fix in the future, which may require some changes to kind of way RBF works today in in Bitcoin D and like other implementations. So
I blame Suhas for not finishing package relay yet.
is he in the crowd?
I don't know if he's here. But blame him either way.
This is also an issue for us. So we offer a channel opening service, and since we are the initiator, we've got to pay the fee. So one of the things we have to sort of cost in is the force close fee. So I mean, if you sell a channel for $2 and the closing fee is like $5 or something, because the fees are high that day or something, like we have to pay that. So one of the reasons why our fees for our channel opening service is so high is because of the current implementation of channels having a fixed, not a fixed fee, a dynamic fee that can be raised really high instead of something that can, I think the new implementation of 1.1 channels where the fee is static and you can just bump it.
Exactly.
Yeah, so.
Yeah, so I think fee bumping is definitely important. And Network L&D will have like ability to actually like kind of like anchor down like a financial transaction. For example, so you can now maybe have like a very low associated per byte when you fee on your financial transaction, and later on increase that slowly up. So I think it's definitely important that like all Lightning implementation are very aware of fees, because like the dumbest thing you can do is basically just use the fee from the estimator and just use that and like that's it. You kind of like, I think the better strategy is to kind of like lowball and use RBF to kind of like slowly get in when you need to, because you don't need to pay 100 Satoshis a byte. That's like wasteful. That kind of like confuse all the other fee estimators as well. So we've been doing a lot of work in L&D to try to make kind of like more fee where to give the user the control, because maybe if you're closing a channel, it may not need to be immediate. Maybe you can do it like in 2 days, and so you can do like a very low fee. So we try to make sure that that information is actually pushed to the end user in the API. We always take many requests in that area.
Right, and that's another great thing about Lightning, just in general, is because there's a lot of transactions that you make in Lightning where, especially opening channels, where you don't really care if it confirms soon, you can actually enforce real security and wait a day or longer for the transaction to confirm, right? Because today, taking transactions at 3 confs, 6 confs, 12 confs is really risky, right? Hash rate is not in any material way secure, and taking transactions in a time frame that is shorter than the amount of time that people can realistically respond to an issue, identify the cause, and fix the issue, which is definitely not 2 hours, then you're introducing a lot of risk. And so the nice thing about Lightning and other layer 2 solutions is you can say, you know what, I'm just going to wait a day for this. And then I'm really sure this isn't going to get reorged out or have any problems.
There's some really exciting work coming down the pipeline in terms of signature aggregation and potentially opening and closing multiple channels in single transactions. Yeah. But I suppose the concern always is if Lightning was an absolute amazing success, is that going to price certain use cases off the Lightning network, or will we need block weight increases? It's probably a discussion for another day.
I mean, we also just don't know, right? Lightning clearly improves the ability to fit more effective transactions on the chain, clearly improves the ability to function and send smaller payments given a certain fee rate. How much, we don't know. We don't know if Lightning results in scaling Bitcoin 10x higher than it was, probably at least, or 1,000x higher. It's probably not 10,000x higher. We don't really know what the number is, right? So we need to deploy it, need users, need to see how things grow. We don't know how far Bitcoin scales. We don't know what fee rates will be in 5 years, right? These are all huge open questions about the Bitcoin system in general. They're not necessarily even specific to Lightning.
And finally, Connor from Lightning Labs has a question for you, Lalu. Is Raiden more scalable than Lightning?
No, because they do weird things like store addresses of like nodes in the chain and look it up rather than using a PDB number for gossip. So I'd say no. But.
So hopefully that makes you feel a bit more comfortable, Connor, about working on Lightning rather than Raiden.
Well, I mean, they're also like much earlier. They have like maybe 40 channels or something like that, or we're in thousands, so it's a very different scale. So.
Cool. So if we have time, I don't know what time we have. What's 3 minutes or 3 questions? Okay. We'll see what questions there are. So yeah, raise your hand if you've got a question. We'll try and fit 3 in or 3 minutes worth of questions in either. So there's a question over here.
Scream, Felix.
Hi. So if there's like a bridge remedy that's like a public transaction, right? Do we know? Because I just saw like one tweet once, like many months ago, that somebody actually, and that was like a mistake or something.
Yeah.
Do we have any statistics on like how many channels were like closed in that way?
Yeah, someone ran a script actually. It was like the SF Bitcoin Devs Socratic meetup. I can't remember the exact details of it, but like you can easily like run a script on chain because like the way the script is, you can actually see when it's like a regular settle and when it's a breach. You can basically do analysis on that. So like I think there's been a good bit. Every now and then people just try to make sure that it works. You know, they breach themselves just to like have assurance in the software itself. But you can run scripts to like know. I don't know any numbers off head.
For me, in my experience, I've had like 5 or 6 breaches.
Yeah.
Probably most of them users accidentally backing up an older state.
Yeah.
I don't think even in our newer node we had any breaches for months.
Okay, cool. Yeah, and hopefully just is zero. Yeah, but yeah.
Any other questions? Yep.
Yeah, hi. I just would like to have you comment about the autopilot and what is expected to change in that. And just going back to the previous presentation as well, is that reputation system is necessary to be built for a more accurate or more useful autopilot feature?
So you're saying when is it going to be more useful, or what was the question?
How much improvement do we expect in the autopilot function?
Yeah.
In the near future.
I'd say a lot.
At least the boss scoring.
Yeah. So a number of things we're doing. Like the current version is basically like a very basic thing, and like the idea was kind of like, okay, let me like try to like make the network kind of like scale free-ish. And I guess maybe from the other presentation, like people has some of that kind of topology. So I think the things we're doing, we're kind of like taking like a two-pronged approach. First, is kind of like using like in graph level metrics to kind of like using things like in degree, liquidity, things like that, and like the idea there is multiple heuristics on like the graph level. You can kind of like combine those to kind of like have it be such that like you'll have particular kind of like catered clusters of those for different use cases. For example, like a client node, a routing node, and maybe like another merchant server. The other thing we're doing as well, we're taking like another approach where we're actually doing kind of like active like network analysis on the network nodes themselves. Because a node can look good, like in terms of it has like a lot of channels, but it could be like managed very poorly, right? So we're going to like combine those two sources of data, kind of like the real-time data from the nodes that actually routing through, and actually the on-chain data themselves, and combine that to have like a better picture of what's actually going on. So today, like pretty soon we'll have like an application coming out, like a mobile app that kind of like combines the two of those together. And we've been testing it today. I bought some beers last night. It's definitely a lot better selection than kind of like, let me pick the biggest node on the map, basically, which doesn't really work out. And people are like learning that slowly themselves too. And definitely a big thing for kind of like, user onboarding. But at the same time, you may want to pick your channel yourself. Maybe it's your own node. Maybe it's like your business or whatever else. So I think we're definitely combining those two.
What was the question over there, Shores?
So Chris Belcher mentioned in his presentation yesterday about probing. So you would connect to one node and you would make fake payments to other nodes. And it's kind of a feature if you want to know what the capacity is and how good the routing is. Mm-hmm. It's also a great way to know in real time what all the balances are and, bad. So what are your thoughts about that? Should it be impossible to probe, but then you can't do good routing? Or, for now, maybe just leave the privacy vulnerability in there? Or
I think we need research. Like, we don't know, there's not any real good research that even says, how do you, you can't like disable probing globally because probing just looks like any other payment, at least while you're receiving it, until it's failed. And you don't know the source of a payment. So you could like charge a fee for it or whatever, but at the end of the day, we also don't know, like, okay, will probabilistically failing certain payments resolve some of the privacy issues? Can you charge enough of a fee on outbound payments or like at relay time so that it becomes prohibitively expensive to try to constantly map the network?
Right, a receiving node.
Research needed.
Receiving node could.
Receiving node is yourself, right? If you're probing, you might like send it back to yourself.
Right, yeah, if you're probing somebody else, they could punish you for it, but if you're probing yourself, then nobody gets to punish anyone.
Well, I mean, like, if I'm in the middle of a payment and it's coming down the line and I'm forwarding it on to someone else, I don't know where it started and I don't know where it went. And so when it fails, I don't know if it was a probe attempt or whether the payment just failed because one of the nodes was offline, or even if I did, I don't know who to punish because I don't know where it came from or where it went.
Yeah, like if you rate limit or anything, you're not sure you're rate limiting a real payment or anything. I know Alex Bosworth, for example, he's probed our node. And he's been telling me, you have this amount of balance and this amount of capacity. You can tell, which is kind of scary. Like, not everything about Lightning is private. Like, even the private channels, they're not necessarily private. They're unannounced. But,
just call them unadvertised.
Unadvertised, not really private. People, like during the Lightning Torch, they were sharing their invoices on Twitter, like exposing their node and UTXOs associated with that. So it's kind of a thing that should be improved.
Yeah. So
At a high level, Lightning privacy is still a big open question.
Yeah.
True. Yeah. Definitely need more research. Need more kind of like field research and go from there. But like I was saying as well, it's like probing is a thing where it's like you can kind of go to like very like extreme defenses, and the defenses maybe would actually decrease the quality of service of the network. Like if everyone just like dropping any like random packet, all of a sudden maybe your pathfinding is a little bit less reliable. So I think we'll have to see like if it becomes a big issue, the things we can do. Probably the best thing is maybe to actually like charge a fee to even make an HTLC at all, and that kind of like at least adds a cost to probing perhaps. But it can also be good, like we're saying, some of the stuff the US has been working on to even like see if a node can route it all effectively. So it's still pretty early, and I guess we'll see where things go. But we're definitely watching the stuff, and like any research paper that comes out in this area, I'm usually reading it pretty quickly. But
I mean, it's useful in the context of making payments. Like, I wouldn't want to take it away. You want to know if the route even is online or has capacity before you actually send the full payment.
Yeah, C Lightning does a lot of probing all the time, always probing in the background.
So does Eclair. It has like a configuration where you can probe how many attempts per second, I think, or something.
oh, before it pays, basically.
Just like all the time.
Okay.
It's just probing the network.
C Lightning does it because they don't announce the channel down flag, the channel offline flag, until they receive a payment, which a probe counts for.
Gotcha.
They have to probe, otherwise their nodes will never announce that a channel has gone offline.
That makes sense. Okay.
Cool. Let's end by, I just want to give Matt an opportunity to plug BetterHash because I think it's really important in terms of potentially miners censoring closing of payment channels in the future. I think BetterHash is really, really important. So
Lightning security is fundamentally broken and a terrible idea until we have better mining protocols. So we should probably do that. And I mean, like in all honesty, accepting payments right now on Bitcoin is really questionable, right? We've seen BGP hijacks against cryptocurrency companies, against cryptocurrency exchanges. We saw one, the most recent malicious BGP hijack that I'm aware of globally was against Amazon AWS, the biggest hosting provider in the world, in order to steal cryptocurrency by hijacking a cryptocurrency website. And the amount of money you could do with a similar attack against Bitcoin miners is potentially much higher than they got against my Ether wallet. So this is not an unrealistic threat model.
Cool. So please thank our panelists. Hopefully you enjoyed that discussion.
Thank you.